Question 18 says a mark on the tip of one blade of a table fan is 24 centimeters from the axle and the axle is 30 centimeters from the table. The fan is turned on when the mark has the position shown. The fan completes one clockwise rotation in 1/4 of a second. Write a sinusoidal function that represents the height of the mark y centimeters above the table x seconds after the fan is turned on. So looking at our diagram here, our fan is turning clockwise, and at this point here, our mark is at the same height as our axle, and we've been told that's 30 centimeters. When it's up here, it's we're adding the length of one of these blades, which we've been told is 24 centimeters. And here at the bottom, we're subtracting from 30 24, one length of the blade, and that leaves us with 6 centimeters above the table. Looking at what kind of function this gives us, we're starting at one point that we can essentially we can think of as like a midpoint, going upwards, coming back to that midpoint, going down, and reaching that midpoint again. So that gives us a sine function where this is our midpoint, the top, passing the midpoint again, our minimum, and reaching that midpoint in one rotation. So we can start putting some values onto this function. Our y-axis is in centimeters, our x-axis is in seconds. And this midpoint here, instead of being 0, it's actually 30 centimeters. Our minimum point here, we said, is 6 centimeters. And our max here is 30 plus 24 centimeters, which is 54. And we can figure out which at what time points each of these the function reaches a maximum or crosses the axis by knowing that this endpoint or one complete rotation is 1/4 of a second. So half of 1/4 is 1/8, which is this midpoint here. Our maximum here is at half of 1/8, which is 1/16, and this minimum here is at 3/16 of a second. So this is our function here that we want to come up with an equation for. So to do that, we will start with the general form of a sine function, which is y equals a times sine of b times x minus h plus k, where a relates to the amplitude of the function, b relates to the phase shift, b relates to the period, h relates to the phase shift, and k is the vertical displacement. So let's start with the amplitude of our function, or a. We know that the amplitude is the distance from our max and min to our midpoint, and so we know that's 24 centimeters because from 30 to 54 is 24, and from 6 to 30 is 24. So our a equals 24. To figure out our period, we know that the period of this function is 1/4. And so if the normal period of the function y equals sine x is 2 pi, we can figure out what b is for our function by saying that 2 pi over the absolute value of b should equal the period of this function, which we said is 1/4. So cross multiplying here, 2 pi times 4 is 8 pi. That equals the absolute value of b. So therefore b in our equation is 8 pi. Then we can look at our vertical displacement. So a normal sine function has a a midpoint or a midline at 0, but ours has a midline at 30, so we've moved upwards by 30, and therefore k, which relates to our vertical displacement, equals 30. And that's positive because we moved upwards. For our phase shift, a normal function starts at 0, and ours does it as well. So we haven't moved left or right at all, and therefore our phase shift and h equals 0. Okay, so plugging in the variables we've found into the general form of the equation, what we get is y equals 24 times sine 8 pi x, because h is 0, plus 30. And so this is our sinusoidal function that represents this scenario here with our table fan. And this is the answer to question 18.